This video is for Math 112, and this is for the last section in Chapter 2, Section 2.5. Let's see. So this is where we put all of the transformations together. All right, so let me write the standard equations. So the word sinusoid, if I use that from time to time, refers to either a sine or a cosine graph. They have similar shapes. A sine bx plus c plus d, or a cosine bx plus c plus d. Okay, so those are the standard equations. You've got information about the effect of A, B, C, and D on the graphs on your formula sheet, which I will include with both the sample midterm as well as the midterm exam itself. So let's go ahead. I recommend that you look through the section. There's 3 good examples in there that give a pretty complete explanation of this process. So I recommend that you look at those. And so I'm gonna run through the problems on page 95, and I think over on 97 I'm going to do one as well. Again, I'm going to skip the matching problems so that you can do those on your own. So let's look at problem 2. Problem 2 is pretty basic. It's similar more to what we were doing in section 2.4, sine of x minus pi. Okay, so first of all, so let me do a little brief thing here. The x-axis is affected by B and C, and the y-axis is affected by A and D. Okay, and again, exactly what those effects are is on your formula sheet, and I'll talk about that as I'm doing the problems. But what I wanted to point out is that here A is 1, D is 0. The y-axis won't be affected, okay? This will be 0, that will be 1, that will be -1, okay? Let's see here. All right, so now what about the x-axis? Well, the period will be 2 pi because b equals 1, all right? But we're going to have a shift here. X minus pi, if we set that equal to 0, that's pretty straightforward. This is going to be shifted out to start at pi. All right. Now, our period is going to be 2 pi, right? So there's a variety of things we can do here, right? If the period, let's see here, period equals 2 pi over b, which in this case is 1. So our period is just 2 pi. That means we're going to get one full period of the graph over a distance of 2 pi, or between pi and 3 pi. Okay? So that's one way you can go about doing this, is to add the period to our starting point, and that'll give you the ending point. The other thing we can do, each of these jumps is going to be 1/4 of that period. In this case, 1/4 of 2 pi is pi over 2. So we want to just keep adding pi over 2. So this is 2 pi over 2. And then we'll go from 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, and 6 pi over 2. That's where we're going to end, which is 3 pi. Okay? So you can do it that way, or you can actually add it on here every single time. There's 4 pi over 2, 5 pi over 2, and then 6 pi over 2. And then we just want to reduce each one of these. This is pi. 3 pi over 2 stays the same. This is going to be 2 pi, 5 pi over 2, and then 6 pi over 2 is 3 pi. So there it is. It's all set up. There's our x-axis. Here's our y-axis. it's a sine function. It's a positive sine function, so it'll start at 0 and go up to the maximum first, back to 0, down to the minimum, and then back to 0 again. So that's problem 2. All right, let's keep moving on these. They will get trickier. And you'll see kind of the level of difficulty that I'll be asking on the midterm when I post that sample midterm. I try not to throw everything in there at once on the tests. I do put problems like that into the assignment so that you get the practice. And then when it comes time for the test, I try to ease up a little bit because it's a time-sensitive situation. I sometimes relate it to the process in baseball whereby somebody who's getting ready to bat puts those metal donuts on their bat while they're swinging it back and forth and getting ready. Then when it's time to go bat, they take them off so the bat feels lighter. So that's what I'm going for here, is that I make the problems a little bit harder in the textbook than I do when it comes time for the test. Okay, so let's take a look at problem 4. Problem 4, we've got 1/2 cosine x plus pi. All right. So let's see here. In terms of the y-axis is a lot simpler to work with than what's going on with the x-axis, because all that has to do with is the amplitude and whether it's been pushed up or down. So d is 0, so our midline is still going to be at 0. Our amplitude is 1/2, so rather than having a maximum of 1, it'll have a maximum of 1/2, and instead of a minimum of -1, we'll have a minimum of -1/2. Now, we do have a phase shift here. Our new starting point, if we set this equal to 0, our new starting point will be -pi. So there's -pi right there. Now again, the value of b here is 1. And so the period is 2pi over b, which in this case is just plain old 2pi. Now again, you can take that and say, well, a distance from here of 2pi will put you out here at positive pi. Okay? So that's one way to look at that. Let's see here. So our starting point is -pi. And each of these jumps here will be 1/4 the period, which, as it was in the last problem, is pi over 2. So this is -2pi over 2, right? That's starting point. Add pi over 2 to it. That makes -1pi over 2. Add pi over 2 to that. That gives us 0. Add pi over 2 to that. That makes pi over 2. Add it on one more time, and that's 2pi over 2, which is just plain old pi. So those are our 5 critical values. 1, 2, 3, 4, 5. There's the ending point at positive pi. There are the other critical values. -pi over 2, 0, pi over 2, and positive pi. All right, so this is a cosine function. It's a positive cosine function, so it starts at the maximum, 0, minimum, 0, and maximum. And that graph will look something like that. Okay, let's keep moving with these. I'm going to do a fair number of these because each one has a little bit different, combination of these factors. And that's part of this process, is identifying what's going on in each problem. All right, problem 6. -2 plus the sine of x plus pi over 6. All right. Now here, just because this -2 is out in front doesn't make it the amplitude. Okay, the amplitude is the coefficient for your trigonometric function. In this case, the amplitude is 1. This -2 is d. All right, it's the vertical displacement. And so that says that our midline here, instead of being at 0, is going to be down at -2. Our amplitude is 1, so that means the maximum will be up at -1. and the minimum will be down at -3. All right, our phase shift, our new starting point, we set that equal to 0 because that's where the normal starting point is. That says our new starting point is going to be -pi/6. And there it is. Now the period, again, B is equal to 1. So our period is again going to be 2 pi. All right? Now each of these jumps, I don't want to draw it on here yet because I'm not sure what it's going to look like, but if this is where we start and this is where we finish, then what I'm talking about here is each of these 4 jumps that produce the 5 critical values is 1/4 of the period. So 1/4 of 2 pi, again, that's pi/2. Okay, so that means we need to take our starting point, -pi/6, and add pi/2 to it. Well, we need common denominators, so let's use 6. So this is going to be 3 pi/6. All right. Plus -1 pi is going to be 2 pi/6. Now we can keep adding this 3 pi/6, right? Because it'll go 2, and then 5 pi/6, and then 8 pi/6, and then 11 pi/6. And then we can also do the actual addition here. There's our 5 pi/6. There's the 8 pi/6, and then there's the 11 pi/6. So let's see here. The starting point, 1, 2, 3, 4, 5. There's our 5 critical values. Let's see, I'll put the ending point out here. 11 pi/6. Chop it up into 4 pieces. And let's see. 2 pi/6, so that's pi/3. And then 5 pi/6. 8 pi/6, that's 4 pi/3. All right, so now we've got the axes all set up. We've got the x-axis, we've got the y-axis. This is a positive sine function, so it'll start at 0, go up to the maximum, 0, minimum, and 0 again. All right, so that's problem 6. Let's see, we haven't seen one that has a period different from 2 pi. That's what number 8 is for. Let's take a look at that one. All right, problem 8. Y equals the sine of 4x plus pi/4, and that's it. All right, so amplitude is 1, vertical displacement is 0, so our y-axis is just a standard y-axis. Okay? Our new starting point, we set 4x plus pi/4 equal to 0. Subtract the pi/4. 4x is -pi/4. And here, divide by 4 or multiply by 1/4. X is going to be -pi/16. Okay. So that's going to be about right there. Now our period is going to be 2 pi/b, which in this case is 2 pi/4, or pi/2. So that start to finish distance is only going to be pi/2, and each of these jumps, right, from the start to the finish, we're going to have 4 jumps. Each of those 4 jumps is 1/4 of the total period. 1/4 times pi/2 is pi/8. So each of these little jumps right here is pi/8. So, again, we need a common denominator, -pi/16 plus pi/8. So let's see, this one, we we need to call it 2 pi over 16. So that when we add that on, that'll give us positive pi over 16. That's going to be our next point here. We're going to skip over that 0 in the middle. And then, let's see here. Pi over 16 plus 2 pi over 16 is 3 pi over 16. And if you get comfortable with this, you know, you can kind of skip some of the work and just count, as long as you've got your denominator set up correctly, 1, 3, 5, 7 pi over 16. Okay? And again, that all just comes from adding that 2 pi over 16 on each time. Okay, so negative pi over 16, positive pi over 16, 3 pi over 16, 5 pi over 16, and we end at 7 pi over 16. It's a positive sine graph, so we start at 0, maximum, 0, minimum, and 0. All right, so that's problem 8. Let's see here. Yeah, let's look at problem 10. All right. Problem 10. Negative 3 sine 6x minus pi. All right, so our amplitude is going to be 3. We don't have any vertical shift. So our midline is going to be at 0. Our maximum will be 3. And the minimum will be negative 3. The phase shift, we set this equal to 0 to find our new starting point. Then our new starting point will be pi over 6. And our period is 2 pi over b, which in this case is 6, right? Okay. So that means our period is going to be pi over 3. And each of these 4 jumps is going to be 1/4 of the period. Or pi over 12. Okay? Each of these little jumps is pi over 12, so then after we do 4 of them, we'll have traveled the full period of pi over 3. So now we need to take our starting point, pi over 6, and add pi over 12 to it. And again, we need a common denominator, so this is 2 pi over 12, and this is 1 pi over 12. So that makes 3 pi over 12. And really, we're just adding 1 pi over 12 every time. So we're going to go 4 pi over 12, 5 pi over 12, 6 pi over 12. Let's see, 1, 2, 3, 4, 5. And that's it. This one needs to be reduced. This one needs to be reduced. And this one needs to get reduced. And again, each one just comes from adding pi over 12 to the previous one, and if you've got common denominators set up, then that's not too tricky. All right, so our starting point is pi over 6, and then we have pi over 4, pi over 3, 5 pi over 12, and pi over 2. All right, so now we've got the x-axis set up, we got the y-axis set up. This is a negative sine graph, all right? So when we start at 0, first we're going to go down to the minimum, back to 0, then up to the maximum, and then back to 0 like that. All right, let's see here. What else? let's look at problem 16. This is -4 sine of 2 times x plus pi over 2. No vertical shift. No, d in this case is 0. Okay? So that means our vertical shift is going to, our midline will be at 0. Our amplitude is 4, so it'll go up to +4 and it'll go down to -4. Now notice that the value of b has been factored out of these parentheses. So I'll use that first to find the period, which is going to be 2 pi over 2, which is pi. Now if we want to find the new starting place, we can take this and set it equal to 0, but we can just divide out that 2 right away. And then our new starting point will be at -pi over 2. Okay, so there's our starting point. And remember, this whole process along the x-axis, each of these jumps will be 1/4 the period, which in this case is pi, and so each of those jumps will be pi over 4. So, we'll start at -pi over 2, and then we want to add on pi over 4, so now we need a common denominator. So this is -2 pi over 4. And so that'll make -1 pi over 4, and then 0, 1 pi over 4, 2 pi over 4, 3 pi over 4, and so on. I'll go ahead and write it out. Pi over 4, and let's see here. 1, 2, 3, 4, and then one more. So that's 2 pi over 4, or +pi over 2. All right, so this thing is actually going to be symmetric about the y-axis. -pi over 2, -pi over 4, then 0, +pi over 4, +pi over 2. So there's our x-axis, there's the y-axis. It's a negative sign function, so we start at 0, go down to the minimum, back to 0, up to the maximum, and then back to 0. All right, we'll look at 2 more of these. Let's see what else we've got. Problem 18. Now this one is kind of jam-packed with everything. 3 plus 2 times the sine of 3 x plus pi over 2. And again, notice that the value of b has been factored out of the parentheses. And also notice that the value for d is in front rather than being in back. All right, let's see here. On the y-axis, first off, our value of d is going to be 3. The amplitude is 2, so that means we'll go up to 5, and we'll go down to 1. Now we need to know, well, let's do the period first again, since that we know that value of b is 3. So let's see, the period is 2 pi over b, so that's 2 pi over 3, and then we just leave it like that. We'll come back to this, cut it, multiply it by 1/4, so that we know how much each of these jumps is going to be. But now we need to know the new starting place. If this is outside the parentheses, that's where you can just divide it out to begin with. And then we'll just get x is -pi over 2. So that's our starting place, is -pi over 2. And let's see, each of these little jumps here, each of these 4 jumps is going to be 1/4 of the period. So let's see, that's going to be 2 pi over 12, which is pi over 6. So each of these little jumps is pi over 6. And so let's go ahead and add those on to our starting point, negative pi over 12. Sorry, negative pi over 2. Let's see, we need a common denominator, so that's going to be a 6. Negative 3 pi over 6 plus 1 pi over 6 is negative 2 pi over 6. And then we'll get negative 1 pi over 6 plus pi over 6 equals 0. And then positive pi over 6. Let's see, 1, 2, 3, 4, 5. That's it. All right, let's see here. So this one needs to be reduced. This is minus pi over 3. So minus pi over 3, minus pi over 6, 0, and positive pi over 6. All right, so we got the x-axis set up, we got the y-axis set up. It's a positive sine graph. We start at 0, maximum, 0, minimum, and back to 0. All right, let's see. I'm going to do one more from this last section here. This one is also has all of the changes in it. Let's go ahead. But this time the period hasn't been factored out of the parentheses. All right, let's see here. Problem 36. What do we have here? Y equals negative 2 sine of 3x minus pi over 2 plus 4. All right. Let's see. So this, the value of d tells us our midline value will be 4. This tells us the amplitude is 2, so it's going to go up to 6, and it's going to go down to 2. Our value for b is 3, so our period is 2 pi over 3. And again, we'll leave that alone for right now. Now let's find the new starting point. 3x minus pi over 2 equals 0. Now in this one, the 3 hasn't been factored out of those parentheses, so if you divide on both sides by 3, it creates some difficulties. So I would recommend that you add the pi over 2 to both sides first, and then divide on both sides by 3. So here, our new starting point is x equals positive pi over 6. So now, we've got to worry about these 4 jumps. Each of these 4 jumps will be 1/4 of the period. So 1/4 times 2 pi over 3, 2 pi over 12, which is pi over 6. So we're starting at pi over 6. Each jump is going to be pi over 6, so we're just going to go 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, and we're going to end at 5 pi over 6. I'll go ahead and write that out, but that's what's going to be happening. 2 pi over 6, 3 pi over 6, 4 pi over 6, and then 5 pi over 6. So, let's see here. A couple of these need to get reduced. Let's see. 2 pi over 6 is pi over 3. 3 pi over 6 is pi over 2. And that one is 2 pi over 3. So we start at pi over 6, and then we go pi over 3, pi over 2, 2 pi over 3, and 5 pi over 6. Let's see. This is a negative sine graph. So we go 0, minimum, 0, maximum. and then back to 0. All right, that's problem 36. Let's look at one more, because these mostly have been sine graphs. I'm going to do 38 is a cosine graph. So let's go ahead and take a look at that one. All right, 38, 2 minus cosine 2x minus pi over 3. All right, so again, the value for d is out in front rather than being in the back here. So d is going to be positive 2. That'll shift that up 2 places. Our amplitude here is 1. So it'll go up to 3 and it'll go down to 1. All right, so there's the y-axis. Now for the x-axis, I'll do the period first again. Let's see, 2 pi over b, which in this case is 2. So our period will be pi. And then our new starting point, 2x minus pi over 3 equals 0. And multiply by a half on each side. Our starting point is pi over 6 again. All right, let's see here. Let's put that in here. And then what? Each of these jumps, right? Each of these 4 jumps is going to be 1/4 of the period, which is pi over 4. So we need to start at pi over 6 and add on pi over 4, 1, 2, 3, 4 times. Well, let's see, we need a common denominator first. So this is 2 pi over 12, and this is 3 pi over 12, right? Because this gets multiplied by 2 over 2, and this one gets multiplied by 3 over 3. So this will be 5 pi over 12, and then if you want to, you can skip count by 3s. 8 pi over 12, 12 pi over 12, 15 pi over 12, 18 pi over 12. So I'll go ahead and write that out so we can take a look at it and then reduce the ones that need to get reduced. 3 pi. Oh, I think I added wrong in my head when I was doing that. 5, 8, 11, 14 is actually how it's going to go. It sounded a little fishy as I was saying it. Let's see here. 1, 2, 3, 4. One more time. Add on that 3 pi over 12. And that's our 14 pi over 12. All right. So we need to reduce these. There's our starting point. There's the next one. This is 4. I was dividing by 2. We got to divide by 4. 2 pi over 3. This one stays the way that it is. And this one, we need to divide by 2. So 7 pi over 6. 1, 2, 3, 4, 5. So we start at pi over 6. 5 pi over 12. 2 pi over 3. 11 pi over 12. 7 pi over 6. And this one, this is a negative cosine graph, so we start at the minimum on that one. 0, maximum, 0, minimum. And again, as I was saying 0 there, I realized it's not 0, it's 2, but it is that midline value. Okay, so you go minimum, midline, maximum, midline, minimum, and so on. Okay. Well, I think that's it for section 2.5. And that's all it's going to be on the midterm. Okay? After the midterm, we will look at some word problems that make use of these concepts. And your second project will be heavily devoted to applying these ideas to physical situations. I really enjoy those application problems. You may or may not enjoy them. They are challenging. That's one of the things that I think is positive about them. They're good. They really make you think about how to apply these concepts to a physical situation. I don't put that on the test though, I save that for a project. So this is the end of what's going to be on the midterm. I'll post another video before the end of the week with a sample midterm. As always, if you have any questions, let me know, please. Thank you.